Hello guys, welcome to my channel. As I made further research about the life and works of one of my favorite mathematicians, Srinivasa Ramanujan. Um, Another notable name case came across in the person of Uday Ban Tewari, who is another Indian mathematician, who will be celebrating his 77th birthday this coming Friday, June 18. I was born on June 18, 1944 at Bedkar. By the way, I have written his name on the board. This is his name, Uday Ban Tewari. So again, he was born on June 18, 1944 at Ambedkar, Nagar, Uttar Pradesh, India. Um, he is currently Emeritus Professor at Indian Institute of Technology, Kanpur, at Kanpur, Uttar Pradesh, India. So his research work includes contribution in the field of group algebra. So I would like to dedicate this video to Professor. Happy birthday. And also I would like to dedicate this video to all my Indian friends, Indian brothers and sisters all over the world. So in this video, I will be discussing about one of the methods used in differentiating functions. This is topic in differential calculus. So a chain rule follows the pattern of if you are given a function like uh, function y and you are told to differentiate in terms of x. Um, Chain rule take use of another variable u and then differentiate y in terms of u and multiply that to the product of the differentiation of u in terms of x. So just like what you see here on the board, this is the pattern followed in chain rule. So anyway, I will show you how to do it. So here we are given y is equal to 2 times the quantity of x cubed minus 1 to the power 5. So here, chain rule. In chain rule, we let this function inside the quantity sign to be equal to another variable u. Okay, u does not include the exponent outside the quantity nor the coefficient for the quantity inside. So letting that as u, okay, we let that as u. We let u as x cubed minus 1. Since we let u be equal to x cubed minus 1, then uh, then du dx, or the derivative of u in terms of x, therefore is equal to 3x or the derivative of 2dx of x cubed minus the ddx of 1, which we know is equal to 0 as we are differentiating a constant. Okay. So we now have du dx equals the derivative of x cubed, where the rule in differentiating a value raised to a power will give us that the value of the coefficient before will be the exponent. 3 and then x, and then the exponent less 1, so we have 3 minus 1 is 2. So therefore our du dx is 3x squared, but that is not yet our final answer. We just have du dx, or this part of our equation to find the dy dx. Okay, so the next thing is to find dy du. So since we let u be equal to x cubed minus 1, follows that our y is equal to 2 times u to the power 5. Okay. So since y is equal to 2u to the power 5, so if we try to differentiate that here, dy du, differentiating y in terms of u, so we have we know that 2 is a constant, and we retain 2. U is differentiating u to the 5th power will give us this exponent will become our coefficient, and then u, and then that 5 will be 1 less, so 5 minus 1 is 4. Okay, proceeding on, we substitute, we can combine 2 and 5, so we can multiply 2 and 5. 2 times 5 is 10, and then we have u to the 4th power. Now we can substitute the original value of u, which is actually x cubed minus 1, so that we will have x, which is the same variable as our du dx, so that later we can combine that. Okay, so we have, which is equal to 10, substituting the u with the original value, we have u is x cubed minus 1 to the power 4. So this is now our dy du. Now following the pattern of dy dx, or the derivative of our original function in terms of x, we can now substitute dy du, the value that we obtained as dy du. So we have dy dx, therefore is equal to dy du times du dx. Substituting the values that we obtained for our dy du, which is 10 times x cubed minus 1 quantity to the 4th power, we have 10 times x cubed minus 1 to the 4th power, and then our du dx, which is 3x squared. It follows, or it implies, that our dy dx therefore is equal to combining 10 or multiplying 10 to 3x squared, we have 30x squared, and what remains here is x cubed minus 1 to the 4th power. So that is the final answer for dy dx given the value of y a while ago. That is the value of our dy dx, or the derivative of y in terms of x, by using chain rule. Okay, I hope you have learned something out from this video, guys. If you learned something out of this video, kindly click the like button below. And if you like to get notified of our proceeding videos, you may click the subscribe button there below, or you may share this video to your friends and other, so that they will learn. God bless, guys.